Hey guys, it's Mike. Welcome back to the shop. No, it's been a couple weeks since I posted a video, and I apologize. I had the worst beginning of the year I've had in a long time. First, my wife's car went down, then immediately my truck went down right after we got her car back, and couldn't afford to have the stuff done in the shop. The initial estimate was $4,000, pretty much a complete engine overhaul. So I moved everything off to the sides of my shop, pulled my truck in the garage, and that's where it sat for a week while I replaced the head gaskets, resurfaced everything, had to do the CV boot, service the transmission, change the transmission pan. One of the things I wanted to get on video that I was really wanted to get on video was machining the flange for the exhaust, which I did at like 2 o'clock in the morning, just jammed it out as fast as I could. I really wanted to get that on footage because it's not something that I typically do, and I wanted to show you guys how I did it. I used or followed the advice of John Mills from Double Boost. Go check his channel out. He did a video on making an exhaust flange, and I followed his advice. I'll show you guys some stills of the flange. I cut it out with the plasma cutter out of a piece of scrap I had. Wish I would have, hindsight, wish I would have used a different piece. The surface, the mating surface was fine, but the outside of it edge looked kind of junky to me. So not the greatest look, but it works. It works perfect. There's no more exhaust leak coming out there. So thank you, John, for your advice on how to set everything up. The fit up was absolutely amazing. Following John's instructions that he did on his video, when I did the fit up, I mean, it was perfect. The pipe lined right back up with the section where I cut it off, and I was able to weld it back together, and my truck is finally done. The other person is Ray Cornelia. He is another YouTube machinist. Go check his channel out. He's got an awesome channel. He also sent me some 17 4pH stainless steel, which I'll turn the camera around and show you guys what that looks like. Alright, so here's the package I got from Ray. Gave me a little note. It says, give this 17.4 stainless steel a spin and let me know if you like it. Be careful when machining, it's sharp. So I had looked it up when he told me he was going to be sending it out, and it is extremely good material. You can see the cut on the end here. He's machined it. I mean, it's just about like a mirror finish on here, and that's how all the surfaces are. Just beautiful. And he gave me these two pieces. They're each just about 7 inches, and I'm going to give these a spin here. This week's video, I'm going to try to get the hydraulic press done and get some practice turning on some of these other materials that people have been giving me over the past few weeks. The other thing I wanted to show you guys was the Rotocut sheet metal hole cutters, and these are the tools that I was waiting for to come in for doing the hydraulic press. So they according to the website for the company, it says that these can cut through a 1/4 inch thick piece of steel, and they look kind of like annular cutters here. I don't know how well you guys can make it out here, but they use this punch here, and it's got a really nice center punch point on it. You chuck it up in your drill and you use that center to find your hole, which I punched all the spots where I'm going to drill through on the hydraulic press, so I can just come back through with these and punch each one of the holes out, which I cut through some 1/4 inch flat plate when I was making the mounting jig for the exhaust, and it worked fantastically. So I'm trying to figure out what size I want the holes to be. I was thinking initially I was just going to do a 1/2 inch pins through, but I think I might jump it up and do 5/8, and these cut a perfect 5/8 hole, and I can pop through on both sides with the 5/8 cutter, and then I can punch out the holes on the crossmember supports and just get a 5/8 hitch pin, which is the biggest size they have down at the local hardware store. So I think that's what I'm going to do. I'm going to switch this out to the 5/8, and we'll get over onto the hydraulic press and cut those holes out. Alright, so here's my big screw up. So when I was building the hydraulic press, I did not think about drilling the holes when I was welding everything together. So now I have the top part completely welded on. Turn the camera so you guys can see. This part is the top. It's welded all the way around both sides, and now I need to drill holes. I wasn't really sure how I was going to do it, but after talking to Randy Richard, I decided to get some of the Hogan rotocutters, and they use a center punch to align to drill the holes out. And they're kind of like an annular cutter for a milling operation, but you can use them with a hand drill. So then I decided to get this so that I can get my holes all exactly the same. So I'll mark this on one corner, put bottom, and the other side put top. I'm going to weld on the base that's going to go across here, and then I'll cut these tacks off. This is just to hold the proper spacing. And once I weld the base on, then I can take this and clamp it lined up with the bottom of each side, and then drill my holes, or mark all the spots where I'm going to drill the holes based off of the pattern from that. And this was like, $6 or something like that at the local hardware store. But I figured this would be an easier way of doing it. I can set my hole pattern, I can go every 4 holes all the way, starting from, I don't know, like around here and going down. And then also, if I ever need to put more holes in or want to put more holes in, I've got this, so I can just throw it back on there and get going. So I'm going to get the bottom piece over here and get it clamped on and get it welded on, at least tacked on tonight. Alright, I've got it cut. This side is the end of the channel, so it's got a little funky shape to it, but it measures out okay, so I've got it cut down to size. Now I'm just going to tack it together. I'll probably just put a couple short tacks on each side here. I might try to get out the little welding box. I'd much rather weld this flat, but I can't really get down on my knees too easily anymore, so I'm gonna just weld it from here, just how it sits. So let me see if I can get my camera angled up inside that welding box. see. Hopefully that turned out alright. I've got some little itty-bitty C-clamps, but I just realized, luckily I caught it in time. The holes are 1/2 inch from this side, but only like 7/16 from this side, so they're slightly offset. So what I'm going to do is I'm going to flush this up against this side, and when I do the other side, I'm going to come off and go under. So I'm doing this with the Hillman sticker from the company up, and I'll line it up at the bottom here and flush up against the side. And I got 2 little C-clamps to clamp it up. My light just shut off. Get my light back on. Alright. Let go for a split second and moved. I have to clamp something else in here because it looks like this piece is bowed just a little bit in the middle. Let's see here. This might work. Alright, I'm going to use a transfer punch first because I think I'll be able to get it in the holes just enough to get it nice and centered, and then I'll go back through and knock them down hard with my other punch. Alright, so I got everything set here, and I just measured the jack that I'm using, and on this end here, which is the top, the jack comes down to about here, and then I've got another piece of I-beam like that. So I'm not probably going to be compressing anything in this top section. So I'm going to start 1, 2, 3, 4, 5, 6 holes down, and then I think I'll go 3 holes in between, and I can find my marker that I just had in my hand. I'm the only person I know that can have something in my hand and lose it when I set it down across the garage. So 3, 3 in between each. I think that'll be more than enough. If I need to add more holes, I can always add more holes later on down the road. So I've got my little transfer punch here, and I'm just going to put a real light punch with this. got this as a Bessie, and I thought it was really cool because you can release it. The problem is it doesn't like to clamp down at all. It's almost like it gets cross-threaded every time I try to back it off at all. Much heavier punch here. Oh crap. I bounced it right out of the hole. More square. Alright, so that's what I'm going to do. And that rotocutter, it has a little guide that you put in the center punch hole. So I'm not going to bore you guys with a bunch of banging and hammering. Finish is coming out all right. Probably need to adjust my feed rate a little bit for this. The chips are coming off and they're not really changing color yet, so I don't think I'm cutting enough off or cutting it fast enough. I'm gonna open my garage door and turn my fans on because it's getting way too smoky in here. Alright, I've adjusted my feed rate a little bit. I had it cut in a 5/1000 feed rate. I bumped it up to 10 and I'm going to take a little bit deeper of a cut here and see how it handles it. leaving an alright finish, but I think I need to slow it down a little bit. The chips are breaking off and just starting to get that hint of blue to them. So I think I'm good on my feed rate, but it's kind of slinging them everywhere right now. I'd rather have them break off short, easy to control chips rather than it just throwing them everywhere. So I'm going to try another cut, a little bit slower RPM. Now it's breaking the chips off, and they're turning that nice purple, blue. But the finish looks horrible on the actual part. I don't know how well it's coming out, but it's just real super grainy feeling. So I think I'm going to go back to trying to get this kind of chip, because this kind of chip had a lot better surface finish. Still getting that sticky look to it. Alright, I gotta clean up some of these chips. I'm gonna shut the camera off and bring you back. Alright, the finish is coming out really rough. I mean, it grabs your finger. If you try to slide your finger over the top, it feels almost like a cat's tongue. Kind of what it looks like too. So I slowed down my feed rate, slowed down my RPMs a little bit, and I'm going to try it again, see if I can get a nice finish. And here I've taken off quite a bit already. I'm right about 1 inch and 7/16 right now, so I've got a little bit more to come off. I am confused. Everything's tight. Let's try a real light cut. Still getting that really rough looking finish. You know, I think I'm gonna grind up a piece of high speed and try that out. Alright, this is some of the Momax Cobalt high speed cutter that I ground with the little chip breaker here. I just honed up the edge again, and we're gonna see how this does. That looks better. I think I might I'm going to try to take a little bit deeper cut and see how it does. I might need to hone a little bit more of a radius on this one. It's not getting as rough, but it's still not getting a good finish. I'll try to do a little bit more honing on that edge and see what I can do. Alright, here's a new... Turn that down so you can hear me. I just ground a little bit more of a radius in the front of this tool, and I'm going to see how it does. Well, it looks quite a bit better, actually. It seems like it actually liked a little bit of a deeper cut there. You know, I think I'm going to check my tool height real quick and see if it needs to be adjusted a little bit. Alright, readjusted the tool height. It was actually a little bit above center, so let's see if it does better now that it's lined up. Well, that finish is coming out a lot nicer. It's still a little bit rough, but it's not as rough as it was, that's for sure. Alright, so I finally got the finish done. The outside dimensions are a little bit smaller, but only by a couple thousandths from what I normally do. And that was just because, if you can see the difference here, this is the finish that I was getting at the end. So I filed this down, and hit it with some emery and some Scotch-Brite and polished it up. So the lathe work is done. It's bored. I can get the camera to drop down here. The bore turned out pretty nice. It feels pretty smooth. I'll probably hit it again before I move it over to the milling machine, just to hit this chamfer on the edge here. But we're pretty much done with this part. Now to throw it, I'll finish knocking that down. There's a little bit of a sharp edge there from when I cut the chamfer, and then the next step will be milling it. Alright, so I've got the part chucked up in my milling machine. I don't know how well it's going to come out, but you can see there's a hole pattern here. What I did is I chuck up a Sharpie, I get everything set, and granted this isn't dead center or anything, but it just gives me an idea of what it'll look like with 5 holes versus 4 holes. And so what I've decided to do with the smaller, like rifle muzzle brakes, I usually do 8 holes around. And what I'll do is I'll offset each row of holes. So I'll have one that starts at 0 and the next one starts at 22.5, so that they're the half, half a movement up, cut around, half a movement up, back to 0, cut around, and it staggers the hole pattern. This is a little bit bigger diameter. This diameter is 1.225. So I decided to go with a 10 hole pattern. And what I'm going to do is I'm going to cut a row of 5, and these are going to be spaced out 300 thousandths center to center. And then I'll cut a row of 5, rotate around, I'll reset back to 0 here, and then I'll go to the halfway point and cut 1, 2, 3, 4, rotate around 1, 2, 3, 4, 5. So I'll just do that all the way around, and that way it'll have a staggered pattern, and the holes will be about that far apart. So instead of it being 45 degrees, it'll be, I think, 36 degrees is what it works out to all the way around. And that way it'll give me an even number of hole pattern, so no matter how the barrel or how the brake is indexed on the barrel, it'll be even all the way around. I'm still going to cut a slot for a sight. This customer's shotgun barrel measures kind of wonky. There's a 3/1000ths difference from the end of the barrel, which is going to be here, to 1 inch back. And he measured 3 different times, 3 different places, and had himself and another person measure, and they all got the same readings. So the press fit is or tolerance fit is basically an average. Normally an average of the 2 measurements, and I have people measure 3 places around. So they'll measure, the barrel's here, and they'll measure 1, 2, 3, and then average, move 1 inch back, measure 3 points, and then average those 2 together, and it usually gets you pretty good. Normally there's not that much of a difference in barrels from the end to 1 inch back, if any. So I'm not sure if it's just manufacturer, or if maybe when they cut, the end flared out just slightly. But the last muzzle brake I made, the customer measurements were slightly off, and it ended up being a slip fit, and he used Permatex retaining compound and put it on, let it cure, and he shot a bunch of rounds through it, and he said it hasn't budged a bit. So I'm confident that this will be a tolerance fit for part of the barrel, and I advise everybody that buys one to use some type of a retaining compound. My recommendation is the Loctite 638. It's expensive, but there's a reason you get what you pay for. With it, it's got an amazing amount of holding force. So we are from here to the beginning of this chamfer is 1 1/4. To the top edge of the chamfer is 1.28. So what I'm going to do is I'm going to touch off on this side. I'm going to move over 1.28 and then move over another 250 thousandths, and then that'll put my center line on par. I'll move an additional 300 thousandths for my first hole, and then I'll touch off on the side. This diameter, like I said, is 1.225, so half of that plus half of my edge finder is 0.8625, so I'll move over 862 thousandths, and that'll bring me to dead center on my first hole. So I'm touched off there, and I need to go 1 inch, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 80, and I'm going to zero this back out again and go another 100, 250. That's got me centered on the edge of that chamfer. I know this is kind of goofy the way I'm doing this, but without a DRO, I like to be a little more certain. And then we'll go 1, 2, 50. We'll make this our new 0 point. Lock our table. Drop down. Let's hit the side. So I gotta reach and block the camera, sorry about that. So our table's zeroed and we need to go 862.5, so 1, 2, 3, 4, 5, 6, 7, 8, 62 and a half. So we are completely locked in there. I'm gonna stop the camera, switch things up, put my drill bit in, and we'll get back to it. All right, we're ready to start our first hole. On the first hole, I just lubed the bit, and you can see there's a little bit hanging off. I'm gonna bring the table up until it's almost touching, and then we'll start our first cut. just figure out where I'm at for the chamfer here before I go too far in. I think I'm just starting to poke through right there. Use a little dripper here. Right, now to see if that hole goes all the way through, which I can't do without my little flashlight here. Oh yeah. And I think that might be sorry about that, my camera went dead. As I was finishing up that hole, I came out and was getting ready to move over and looked down and there's nothing there. Alright, and that is it for our holes. You guys can see it turned out looking pretty nice. I'm happy with it. So next is back out and cut this slot for the front sight. And we are done with this. Now I just need to get it back in the lathe, make my measurements for parting off, and we're done. Alright, now I'll just flip her around and clean up this side. I cut it just a hair long so that I can face it and chamfer the edges, and then I'll make a cleanup pass through the bore